Okay, we are live. Welcome back. I'm actually pretty glad to see a couple of viewers coming into the live stream. So I'm sorry if I don't always notice uh, your comments while in the live stream. I've been I'm not very accustomed to doing live stream with an audience. I do these to document what I'm doing. Um, but if I'm going to start to regularly getting viewers coming in, I would be more than happy to have a chat with y'all. But perhaps there's something that I'll learn as I go. But for now, I'm gonna continue on what we were doing, which is trying to implement this deep zoom postmodern debugger concept. Um, and I thought about how I'm gonna proceed during my break. I think it would be good educational experience to sort of build this zooming interface from the ground up, but using my file explorer as a starting point, maybe, or as a reference, let's say. Okay, so the way I'm gonna do that is let's go to that file explorer project and run it. First, I want to show you how. Now, I did make another YouTube video that explains how that one works, so I'm not gonna go all the way into it, but I'll show you a little bit of how that guy works. This one actually needs a server and the client side. npm run server to run the server. What the heck? Maybe on my phone I will. Okay, there's the server. I'm gonna try to see if I can join my live stream on my phone. Okay, so I was able to do that. Okay, this is interesting. So I'm joined. Okay. So I'm looking at my phone, or I have the ability to look at my phone, I should say. And I have the ability to chat. I'm gonna say hello. Okay. So in case anybody logs into the stream, maybe I can look over to my phone and notice that. Okay. So I have so we're looking at the File Explorer program, which I call Deep Zoom. I am running the server. Now I'm gonna run the client side, and just hoping that it works. So the last several weeks, I had this laptop sort of out of commission. It was broken and in the process of being fixed. I finally fixed it, and so now I'm using a different computer from the one that I was using then. So I haven't ran this example on this computer yet. This is the first time. See if it works. It's taking a while. Oh, it does appear to work. Okay. Wow. All right. So it works, but it's kind of not as performant as I remembered. I think that's because of the large amount of probably because I'm streaming is one, and another reason is probably because how many directories I have in this computer's playground directory compared to that one. but still, I feel like this is kind of slow, so I think there's room for improvement of improving this guy's performance. There's a thing called oiler. I wonder what that is. That doesn't seem to have a lot in there. Okay, so anyway, so this is the File Explorer zooming interface. If I went into something that, say, had more content in it, like this one, then you see that level of detail, right? This one has a lot of PNGs in it. What even is this? This is called the Punch Card Methods book. Oh, it's a book. Punch card. Too bad I don't have a preview for images. Maybe I should add a preview mechanism for images that will allow me to see what those images are. Yes. I feel like that would be very fun to do. There's a to do, no ifs. What is no ifs? Example of how to write code without using if statements. That's interesting. I don't see any code inside though. Okay. I don't know what's going on here. So anyway, that's the zooming interface. We want to sort of utilize this concept in this debugger. So I'm gonna kind of start from square one. We're not gonna throw away what we did in the last session. It's just that we're going to perhaps pause on it. Pause on it. So we're still gonna do this stuff. It's just that, let me see, where should I make the cut is what I'm trying to figure out right now. I have this render function, I have a few other helper functions. Perhaps what I'm gonna do is, for now, I'm not gonna call this render function. It's printing out this history. Yeah, let me bring in, I'm not even gonna fetch these code. I'm gonna comment out this code as well. Oops. I'm gonna comment out this code that fetches the file and parses the file. I'm gonna comment all that out. And now I'm going to sort of bring in the code from the File Explorer bit by bit. I'm gonna bring in the fit text function, which actually needs some accompanying functions, including the text measurer, because the fit text function has to take a text measure as an argument. Okay. I think I am going to make that a separate file. It also needs a helper function called, well, we'll see. We'll see. Oh no, I think I got rid of the other helper function. Okay. So I'm gonna make a, make a fit text function file, fit text ts. I might publish this as an npm module at some point because I have had to use this for several projects now. The font setting thing, okay, where is the font setting? Font setting is that. That's the font setting. We have a text measure, bounding box. Bounding box is that. Okay, so, alright. Sounds good. These are unused. Oh, any type. Height and width, are we using these? Excuse me. Excuse me. Sorry. So these should be numbers. Okay, so I think that's the fit text function. I'm gonna export each of these things so the importing file can use them. Okay. Alright, so I have a fit text function and I'm able to use it for the debugger. And now I want to implement this zooming and this viewport scheme. Okay, so how do we do that? Where's the viewport defined? I have this text measure which I know I will need, so I'm gonna go ahead and make that. It's gonna need the canvas context, so I'll grant it the canvas context right there. We have this request render thing, which calls request animation frame and gives it the render function. We will probably also do that, but I won't do that just yet. We'll need this wheel thing, and we'll need to, I'm gonna steal this whole thing actually. We'll need all of these coordinate functions too, I think. The render code will be different, and we won't need any caching at all, which is nice actually. There's aspects of this debugger that's simpler than the file explorer actually. Okay, I'm gonna actually steal this code here and paste it in. I need a viewport. Where was the viewport defined? Oh, there it is. So I'm gonna steal the viewport. Put it at the top. Oh, the viewport wants reference to the canvas, so I'll move it down. Okay. Let's see. And then there's this request render. Okay, so we do have this render function already. So why don't we let's go ahead and steal the request render function. Okay, why is there a problem here? Filter does not exist on type history. Oh, because we commented out these lines over here. Okay. Maybe I'll uncomment these. Okay. What now? Bounding box. I can add the import to bounding box. Okay. Okay, and I suppose at the very beginning I should request render. Does it render? There, it does render. Okay, so now we to implement zooming, and the way to make zooming actually have an effect is to have this render be based on the viewport, as in if the viewport zooms in, I actually want to render the output relative to that viewport, and that's important. How do we do that? Where even is the viewport? So perhaps we draw a box we did the viewport to be like half of the height of the canvas, half of the width, negative half of the height of the canvas. So which means like let's as in here, is that what that means? I'm kind of confused actually. The 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 fact that as in, because this is 0 0, the top, yeah, this is how this works. This is 0 0, and I forgot what I think this is supposed to be the canvas height and the canvas width, I believe. Yeah, I believe so, actually. So this is, which I think for the file explorer, we have, we based it on the window size. I see. Except we have zoomed out. So whatever this window size is, I'll figure out what it actually is. Although it's gonna change it once I open up the DevTools. So I'm using window.innerWidth and window.innerHeight to figure out the size of the actual viewport. I'll do inner height, let's see. Okay, inner height is 698. So I think that means this is 698. It's weird we're doing math like this. But it's saying we did the render function is actually going to use the canvas width and height, I believe, as its coordinate system. Yeah, it's gonna tell it to render within this bounding box, except we've zoomed out. So this is really weird and difficult to explain at this point. So let's say I'm gonna say like, so this is 698, and if that was 698, this is gonna be like, I don't know, 1200. 1200. But this is supposed to be 0 0, and this is supposed to be 1200 by 698. But as you know, that's not really true, because the width of this whole thing, that's actually 1200, and the height of this whole thing, that's actually 698. So how can we say this is 12? That's because we set the zoom factor to 0.5. We zoomed it out. That was done. Here, we set the zoom to 0.5, which makes it sort of make sense. So this is like reduced the render from the perspective of the renderer. This is 0 0, and this is 1200 698. But from the but it everything goes through this zoom scaling factor when you draw. So before the renderer actually draws anything, it multiplies this, and it also offsets the top and the left by by that amount. Oops, by that amount. So that's the offset. Okay, so that's the offset, and that's what the viewport is. The viewport is the combination of this number and this offset number, which is x, y coordinate. That tells us what the offset is. And whenever you zoom, you increase this number, you increase the zoom, but you have to also recalculate the offset based on where you're zooming into, based on what the coordinates. So what I'm trying to figure out right now is how to first I want to verify that the code I copied over is correct, and we've got it wired up correctly. So what I'm thinking right now is just draw a box somewhere in the middle of the screen given the zoom level. So let's say I'm just gonna draw a box that is the size of the supposed canvas, but we'll zoom it out by factor of 0.5 as we have done previously. Oh no, I want the other program. Okay, so I think I'm actually gonna, for the moment, comment out all of this. And then I'm gonna get this canvas context. I'm gonna say fill rect. There's gonna be this box world to canvas function, which I probably copied over. Maybe. Yes, there is. So I'm gonna use this coordinate conversion routine to convert a bounding box to the canvas coordinate. And a bounding box is something that has a top, left, and width and height. I'm gonna say top is 0, left is 0, width is canvas dot width, and height is canvas dot height. Box. Now we're gonna have a box in canvas coordinates, and I'm gonna say box left, box top, x and y, and then box width and box height. So basically, as long as you use this conversion function to convert a bounding box from the world coordinate to the canvas coordinate, then you're okay. I think that's the idea. See if that worked. Okay. Whoa, mama. It sort of worked, I think. If you zoom in, there you go. That's the zooming in going. Okay. In order for the smearing to not happen, we're gonna need to clear out the canvas, which is done by CT clear canvas, or maybe just fill clear rect. Did I use clear rect? I did. Okay. Clear rect 0, 0 canvas dot width, canvas dot height. But this version, this clear rect, we didn't do the coordinate conversion because we actually want to clear out the canvas in its coordinate system. Okay, see if that worked. Yeah, that kind of worked. Does the drag work? The drag doesn't appear to be working. The drag to pan, that works via some additional support functions which require the mouse movements to be tracked. So let's bring those functions over as well. So that's this mouse up. So if mouse down, if we get a mouse down on the window, we're gonna set dragging to true. If mouse up, we're gonna set dragging to false. But when we start dragging, we remember the offset from that point. And then once it's dragging, when we're tracking the mouse movements, every time you move the mouse while you're dragging, it's gonna recalculate the viewport. I'm gonna, and this code took me a long time to figure out that this math calculation. So I'm not sure I want to explain it or not. How it works. But let me see. Okay, we need a drag start X and a drag start Y as well. So I'm gonna copy those over. Okay, so I think with that you can drag this viewport as well to pan. Yep, that works. That's actually beautiful. And you can zoom and you can pan. And currently it's just a box. So not that interesting. But this stuff works. Let me think. So this is basically saying as long as you draw within like let's say if this was your bounding box that you were given to draw, box. Oh, I have duplicate variable names. So I'll call this real box. Real box. Box and real box. Okay. So you were given this box and you were told, hey, can you draw within this box? Then you would call this function to translate the coordinates that you're drawing to the coordinates to that, and then that is the actual coordinate you should use to draw with. So as long as your render function follows that rule in all the places, it should be fine. That's the idea. Yeah, so if we were to adapt this code here that draws the code to that, then we would want to use the fit text function to draw within this real box. Yeah. Let me think. Yeah. And so we shouldn't use this fill text directly to draw. Instead, we should use the fit text function to draw text. Let me think about that. Let me stroke this rect so that I get a visual of the box I'm supposed to draw into. Okay, there it is. I'm gonna make the canvas smaller because now that we have zooming and panning, we actually don't need to make it long just to fit all the text in. Okay, so this is the box that we're supposed to draw into, and you can zoom in and zoom out using the scroll wheel. Now we're gonna draw this code onto it. Okay, I'm gonna leave this stroke rect here, but this code that we've been drawing, I'm gonna draw the code onto that box. How are we gonna do that? Instead of saying fill text, fit text currently doesn't work with colored text, so we'll have to add that back in. But for now, we'll not have different colored text. We'll just have all black text until we fix that. So what I'm thinking is we're just gonna buffer the lines that are going to be drawn, and then we're gonna ask fit text to draw them. So make an array called output lines, which is gonna be an array of strings. And then anytime we want to actually draw a line, anytime we want to actually draw a line, we're gonna just append a line or push a line into output lines. And when there's a line number, we're actually just going to maybe do a pad. I think strings can pad now. Pad and 0, 0, 0. How do you do this pad thing? Like pad to 5. I see. I'm gonna say pad start then. Maybe. So yeah. So if it's a number 1, it'll go there. I think it'll pad end actually. 1, but if it's 125, it'll look like that. Okay, that's what we'll use. Okay, so pad end 5 spaces for the line number, probably enough, and then plus the actual line. Okay, and then we're gonna loop through. We're not gonna need this vertical offset thing anymore because we're not drawing the text ourselves. We're gonna do the same thing. Push the lines onto the output lines array, and then here we can't do blue text anymore. Actually, this is another entry onto the same line, so perhaps I should have I'm just gonna have an output line be like this, and then this output line, we're gonna add more stuff to the output line. Maybe we'll do a pad end as well. Yeah, 80 columns. I can tweak it to make that better later because you may not need 80 columns, but now I'm gonna say I'm gonna add this to the line, the display of the variable name value to the line, although I won't get that at first go. Now I'm gonna push this output line to output lines plural, like so, and then at the end we can get all of the output as output lines.join. And then that's the output we want to draw. And then we're going to ask fit text to do it. Where's fit text? Oh, come on. Oh, come on. We have fit text here. Font family. The font weight, normal. Bounding box. Good question. Real box? I think so. Yeah. Real box. Text measure. I think I made that. Oh, and that was it. I think I don't need to do this one. Let's just see what happens. num_node.paddn is because that's a number, not a string, and paddn is a method of a string. So I actually need to convert line no into a string before I can do paddn. Try that. There it is. Okay. We can zoom in, zoom out. Why is it so small? I'm not totally sure why it's so small. Okay, interesting. Probably because of this padding that is so small. If I change that to 40, it would probably be, the text would probably show up larger. Yes, I was right about that. Okay, so what I could do there is find the longest line out of all of the code that are to be displayed. So longest line length is code. Actually, it has to do with entries this frame. Entries this frame reduce longest length entry. And then we start with 0, but if line no from the entry, get the actual line. So if line length is greater than longest length, then return line.length, else return longest length. That's how that works. And this guy I'm going to use here, maybe +1, +5. Let's try that. So now should depend on the actual code how long it needs to be, except that didn't work. 134, we had an error here. Line, we didn't get what's code lines? Do you have code lines set, initialized? Yes. We couldn't get line. Oh, this is not line no, this is just line. In the actual history file, it's not called line no, it's just called line. Okay, I think that worked. Okay, so that's kind of cool, I guess. But and you can zoom in. It's not that fast. That's something we'll need to work on, is to make this rendering faster so that it zooms smoothly. Okay, so I was actually thinking, like I said before, initially it actually maybe just say main instead of saying that. Initially, maybe you just have it say main, and then only when you zoom in to a certain scale do you show the code. So maybe we do that. That'll be fun. So how do we do that? So let's do initially the scaling factor. Called it like, let me steal some code from this file zooming thing. That's the scaling factor. So we first calculate like the area, my canvas box. Okay, so the area of the box that's being rendered, that which I'm calling real box. Real box. Maybe call it my box. Alright, I'm gonna call it my box. Though I can't tell the editor to rename, or can I? My. No. Okay, calling that my box. And also when I fit text, we fit it into my box as well. Okay. Okay, so I want to say the area, my area, is my box dot width times my box dot height, and the if that is if so ratio my area ratio versus the actual canvas area is the my area ratio. So I'm gonna say my area ratio is greater than 0.6 or 0.5. Let's go with 0.5. And I'm gonna render this code. But if not, then I'm going to, well, I'm gonna flip the conditional hash. Else I'm gonna render this code. If it's less than 0.05, then I'm not gonna render the code. I'm just gonna render the name, which I think is just gonna be the name of le function. I'm gonna have the fun name. So I'll yank that out. At the fun name. Fit text, just the context, the fun name plus parentheses, and then code font family, and then normal, my box, text measure, and that's it. Main, and if I zoom in, then I get to see it. If I don't, then I don't get to see it. Okay, that is what I wanted. Ooh, I like it. I like it a lot. Except, why isn't it centered? I was expecting it to be centered. Kinda. did I do this thing where text baseline is top? Is that right? Okay, that's better. I think the fit text, I think the fit text function was not designed with text baseline top, and that's why. Okay, I like this a lot. So then, now that we have this thing going on, I think the next thing is if we can get this zooming to zoom into this fib function, as in this fib is also a box. Maybe we even put a little box around this fib thing. That's interesting how we would do that. But then again, you zoom close enough to this fib and you start seeing the code within this fib function. That was my idea. There's also the timeline idea, which, let me think, which had to do with, like, if you had a timeline, I'm not sure, maybe I don't tackle the timeline idea now. We'll wait until the other stuff is done. But we had the timeline idea, which was meant to be like, this is the starting, this is the beginning of the execution of the main function, and then this is the end. And then if we zoom in, then the timeline would also be zoomed in, I would think. So if you zoomed in, then now if you want the timeline to be truthful and be aligned with the code execution, then it would be like, there's a timeline here, and this is a piece of code. This is subroutine call, and it would have a starting time and an ending time as well. However, because this is a syntax element, it's a piece of code within a number of lines of code. If you wanted this to align the timeline, as in if this fib function took a really long time to execute versus another call to it that took less time to execute, like let's say it was like let me draw it out to show me what I mean. Maybe I make a new tab. Oops. All right, to show you what I mean. So let's say you had, you know, a function A. Oh, this color is not great. Let me try again. Function A and function B, and you had a timeline. What if function A took a lot longer than function B, and you want that to be represented and sort of matched up against the timeline? Then function A would probably take up a whole lot more space than function B, so it might look like oops, I should probably have written it like A of X, because I called it function A, and then B of X, I don't know, it should have looked like this, and that kind of skews the actual source code. So this is being the timeline. So this is the point in time, the start of A, and this would be, say, end of A. This would be start of B, and this would be end of B. So if we did this, that kind of skews the source code presentation, because let's say the like if the result of A was passed to print, for example, then the print would look like this. This is a parenthesis, and this is a parenthesis, and then maybe we're also gonna print the result of B. Then it will look like this, and that's what we do. But it may look weird, and perhaps there is a mode in which this is how it works, and there's another mode where this skewing does not happen. I'm not sure how we want to handle this, but this is interesting area for experimentation. But I'm thinking right now that for the first attempt at this idea, that we don't do the skewing. And I think that means like this, we just have to find this text and draw a little box around it, perhaps. How would we do that? Because fit text doesn't exactly do that. And that's interesting. Okay. So let me think about that. I'm gonna take a break from this stream for now. While I think about that, I don't know if I'm gonna do another session today or not, but if not, then that will have to wait until Friday. If we do, then I'll see you soon. See you not that long from now.